All right. What is up, everybody? Tom McGurl back at it with another video of the Rust programming language book. If you're watching it live, we're doing it on a Wednesday. Usually we do this on Tuesdays, 9 p.m. to 11 p.m., but we did it on a Wednesday because Tuesday, as some of you may know, is election day here in the U.S. So I hope you were able to get out there and vote if you were eligible to do so. And yeah, we're here on a Wednesday. After this, we will be going back to the regular Tuesday schedule. That's Tuesday nights, 9 p.m. Eastern to 11 p.m. Eastern, or however long. Sometimes we go a little bit over, sometimes we come up a little short. We'll see. Tonight, what we're going to be doing is Chapter 9 of the book. Last week, we were going to see if we can get into Chapter 9, but we ended up spending the entire time doing the Chapter 8 exercises. They ended up being really fun. Hope you're able to check that out. If not, do not be upset because we have all of those videos posted here on YouTube. Just constantly plugging this in the beginning, but it's for the folks that missed out on some of the previous sessions. You can find them all here on my YouTube channel. I will put the link to that in the chat, but you can find it also by just searching my name, Tom McGurl, on YouTube. It should come right up. You can see we have our Part 8 here. It was our spooky Halloween edition. It was very fun. Had a lot of activity in the chat. We were doing some exercises, so definitely check that out. All of the other chapters from chapter 1 to 8 are up, as well as some other videos, one on coding up a AWS Lambda serverless backend with DynamoDB. We wrote that in TypeScript and Node, and also leveraged S3 for some image storage. And then prior to that, we did a React Native app to check out Recoil.js, which we might return to. I've gotten some folks have mentioned that they're interested in returning to Recoil.js and checking more of that out, so may do that in the future. But yeah, check out that series as well. Also, plug, if you follow me on Twitter, my Twitter handle is right there above, Tom_McGurl. You'll get updates for when I go live, as well as other random JavaScript, potentially video game stuff there for you as well. And if you want to follow along with the code, you can always check out the GitHub repo. Here you see we have our Learn Rust Live. This is where you can find all the code from what we're doing here. Basically, you can see here we have all the chapters we're getting pushed up to this repo. So pull it down, follow along, or follow along on your own, whatever you want. But this is here for you to reference if you need it. But all right, that brings us to our main event, Chapter 9. So last week we covered the exercises from Chapter 8. Now, Chapter 8 was all about collections, common collections. And we wrote those exercises, which were at the end of Chapter 8 here. They presented us with a few different exercises. Make a word work in Pig Latin, create a way to add like a company directory where we type something and add somebody to a directory using a map, as well as computing the mean, median, and mode of a list of numbers. And so that code can be found in the repo, obviously, but we have here under Chapter 8 collections, we have exercises. And here we have our exercises. So we had our main function, which we were just calling different things. We have our directory. This is the program where we type in whether we want to add an employee to a certain directory. We had convert to Pig Latin, mean, median, and mode. So you can find that all in the exercises project. Now, one of the things we came across while we were doing that is we needed to handle errors, right? And that's the chapter we're going to be covering today. It's all about error handling. We've done some of it in the past, right? We've done panics. We've done catches. You see that we've done some here even where we have an option type, right? If we have some, we do something. If we have none, we do something else. Maybe we continue. Maybe we panic. So we've done a little bit here. You can see an example. We're expecting, right? We try to read the line. If it fails, we use the expect. We're going to dive more into that today, and I'm pretty excited. So let's take a look. Chapter 9, error handling. Before we begin, you know it, we always got to do it. Just want to jump up to the front here and give a shout out to the authors, Steve Klobnik, Carol Nichols, and anyone from the Rust community that has contributed to this book. We really appreciate it. Couldn't be here doing this without you. I'm learning a lot from the book. It's been extremely valuable. It's pointing me in the right direction. It's been awesome to do the live stream. So shout out to the authors, again, Steve Klobnik, Carol Nichols, for doing a phenomenal job of organizing this book, and also for pushing a lot of stuff to chapter 10, which we're going to get to probably next Tuesday. If you've been following along, you know the long-awaited chapter 10. It's come up a bunch everywhere. It's like, oh, this will come up in chapter 10, chapter 10. So I know this is going to be a crazy chapter. I'm excited for it, but we're not there yet. We got to start with chapter 9, right? All right, let's dive in. Error handling. Rust's commitment to reliability extends to error handling. Errors are a fact of life in software, so Rust has a number of features for handling situations in which something goes wrong. In many cases, Rust requires you to acknowledge the possibility of an error and take some action before your code will compile, right? So it's going to say, this can result in an error. It's possible. Make sure you handle it, or we're not going to let you compile the code, which is a nice restriction, right? And not something we'd find in other languages. Some languages, but not all. This requirement makes your program more robust by ensuring that you'll discover errors and handle them appropriately before you've deployed your code to production. That's what we want to avoid, right? We want to avoid errors in production. We don't mind if we see them in development. Obviously, we mind if we keep seeing them, we can't get past them. But if we can catch them early, they won't become a problem in production. And that's why it makes Rust an attractive language for writing programs that you know you don't want to fail. Not that any of us want a program to fail, but when we really need that safety. Rust groups error into two major categories: recoverable errors and unrecoverable errors. For a recoverable error, such as a file not found error, it's reasonable to report the problem to the user and retry the operation, right? You wouldn't want to just crash the app. You'd say, hey, we can't find the file you're looking for. Try another file. Unrecoverable errors are always symptoms of bugs. So they happen in an unexpected way as a symptom of a bug, like trying to access a location beyond the end of an array. Let's say you have an array with a first name, last name. You try to access a third, something at index 2, right? The third thing in the list, and it's not there. That's a bug. And so that's an unexpected error. Most languages don't distinguish between these two kinds of errors and handle both in the same way using mechanisms such as exceptions. Rust doesn't have exceptions. Instead, it has the type result, T, E, those are generic, for recoverable errors, and the panic macro that stops execution when the program encounters an unrecoverable error. This chapter covers calling panic first, and then talks about result T, E values. So we're going to cover the panic first, then we're going to talk about that. Additionally, we'll explore considerations when deciding whether to try to recover from an error or to stop execution. All right, that's pretty cool. We don't, like, sometimes, we may want to panic, maybe we want to continue the execution. We'll talk about those, so that's pretty sweet. All right, unrecoverable errors with panic, right? Panic at the Disco, you listen to them, maybe in high school, whatever. Sometimes bad things happen in your code, and there's nothing you can do about it. In these cases, Rust has panic. It's a macro. When the panic macro executes, your program will print a failure message, unwind and clean up the stack, and then quit. This most commonly occurs when a bug of some kind has been detected and it's not clear to the programmer how to handle the error. So it's a bug's detected, we don't know what to do, we panic, it's unexpected, it's out of the ordinary. Let's check out this little note thing they have here. Unwinding the stack or aborting in response to a panic. By default, when a panic occurs, the program will start unwinding, which means Rust walks back up the stack and cleans up the data from each function it encounters. But this walking back and cleanup is a lot of work. The alternative is to immediately abort, just back out, which ends the program without cleaning up. Memory that the program was using will then need to be cleaned up by the operating system. If in your project you need to make the resulting binary as small as possible, you should switch from unwinding to aborting upon a panic by adding panic equals abort to the appropriate profile sections in your cargo toml file. For example, if you want to abort on panic in release mode, add this. So let's just look at that a little closer. So if in your project you need to make sure the resulting binary as small as possible, it looks like there might be a typo. No, if in your project you need to make the resulting binary, so if you need to make it as small as possible, you can switch from unwinding to aborting upon panic. So we can add this to our toml. Let's try calling panic in a simple program. Okay, so I'm going to create, Let me move this over here, pull this up, move this over here, and I'm gonna create a new project for it. So let me close out some of this other stuff here we got. Let's close that out, close that out, close that. We don't need to save that. Let's get all this stuff out of here. No, we don't need to save that. No, we're good. Okay. All right, so we have chapter 8, collections. I'm gonna make a new folder called chapter 9. All right, so go into projects, make dir chapter 9, error handling. Let's cd into that chapter. And what I'm going to do is I'm going to create a new project called panic, errors with panic, let's say. Or we'll call it unrecoverable errors. So cargo new unrecoverable errors. cd into there. And we'll open that up here, and we have our main file now. And so we're gonna try calling panic in a simple program. So let's call panic, and we'll say crash and burn. I like that. Crash and burn. Now let's try running the project, cargo run. So you can see the output here. Let me move myself to the right, or the left here. So you can see the output here. Unrecoverable errors. Thread main panicked at crash and burn. It tells you what line, 2.5. Note, run with Rust Backtrace 1 environment variable display Backtrace. Let's try that. Okay, did I type it right? Run with Rust Backtrace. Rust Backtrace equals 1. But it didn't display a backtrace. Interesting. All right, well, anyway, let's just keep seeing what they're telling us over here. When you run the program, you'll see something like this. And we just saw that. Perfect. Let's get this out of here. There we go, much better. Okay, so here, we're going to figure out how to use the backtrace. The call to panic causes the error message contained in the last 2 lines. The first line shows our panic message and the place in our source code where the panic occurred, which is line 2. It indicates that it's the second line, 5th character of our main RS function. So you can think of it as like columns or character in, right? In this case, the line indicated is part of our code. And if we go to that line, we'll see the panic macro call. In other cases, the panic call might be in code that our code calls. And the file name and line number reported by the error message will be someone else's code where the panic macro is called. So it might not be our call. It might be a third-party library or something, not the line of our code that eventually led to the panic. We can use the backtrace of the functions. We can use the backtrace of the functions the panic call came from to figure out the part of our code that is causing the problem. So we can use backtrace to figure out what is ultimately causing this issue. We'll discuss what a backtrace is in more detail next. Using a panic backtrace. Let's look at another example to see what it's like when a panic call comes from a library because of a bug in our code instead of from calling the macro directly. So instead of our code calling panic, it's called as a result of some library code. Listing 9.1 has some code that attempts to access an element by index in a vector. So let's do that. So let's go let v equal, we're going to create a vector, 1, 2, 3, and we will say v. We'll call index 99, which definitely doesn't exist, right? And let's go ahead and run that. So let me move over here. Get out of your way there. All right, so we're gonna run cargo run. All right, so it says here, thread main panicked at index out of bounds. The len is 3, but the index is 99. Source main 4, 5, so it says right here. And so let's see what they're telling us on the left side here. So here we're attempting to access the 100th element of our vector at index 99. But it has only 3 elements. In this situation, Rust will panic. Using the bracket notation is supposed to return an element, but if you pass an invalid index, there's no element that Rust could return. Here, that would be correct, right? Because it's out of bounds. It only has 3 elements. It can't access the 100th element at index 99. In C, attempting to read beyond the end of the data structure is undefined behavior. You might get whatever is at the location of memory that could correspond to that element in the data structure, even though the memory doesn't belong to that structure. So you might get something totally out of the ordinary, right? This is called buffer overread. You're reading beyond your buffer and can lead to security vulnerabilities if an attacker is able to manipulate the index in such a way as to read data that it shouldn't be able to that is stored after that data structure. So it's almost like if you have your block of memory, right? Let's say you have a block of different memory, and let's say it's about this long, and this part of it is taken up by your array structure. In Rust, if you try to access this region using myArray and the bracket notation, it's going to be an issue. It's out of bounds. You can't do it. But in C, it might give you whatever is at that index in memory, right? Because everything's just stored sequentially in memory in this case. So it might give you a value, and people can use that as a potential vulnerability in your code as an attack vector. To protect your program from this sort of vulnerability, if you try to read an element at an index that doesn't exist, Rust will stop execution and refuse to continue. Let's try it and see. All right, cool. So you can see here, main panicked out of bounds. It tells you right here, same thing we had on our side. The error points at a file that we didn't write. So let's look. On mine here, it says, well, actually, in my case, it's pointing at main. It doesn't look like it's pointing at a different file. Maybe it's changed since this has been written. I don't know. Let's see though. Let's see where they're getting with it. The error points to the file we didn't write. That's the implementation of slice in the Rust source code. The code gets run when we use the vector, the bracket notation on the vector, and that is where the panic actually happened. The next note on that line tells us that we can set the Rust backtrace environment variable to get a backtrace of exactly what happened to cause the error. A backtrace is a list of all the functions that have been called to get to this point. Backtraces in Rust work as they do in other languages. The key to reading the backtrace is to start from the top and read until you see files you wrote. So we're going to go from the top down, right? That's the spot where the problem originated. The lines above the lines mentioning your file are the code that your code called. The lines below are code that called your code. These lines might include core Rust code, standard library code, or crates that you're using. Let's try getting a backtrace by setting the Rust backtrace environment variable to any value except 0. Listing 9.2 shows the output similar to what you'll see. Okay, so let's do that. So we have to set it first. So I'm going to move myself over here to the bottom left, so I'm out of your way. Oh, sorry. So I'm in the bottom left, and now I can run this code. So I'm just going to run clear, and we're going to run Rust backtrace equals 1 cargo run. Cool. So we got a little backtrace here. Let me just move this out of your way so we can see what we got. So let's look. We see it panicked at index out of bounds, the length 3, but the index is 99. Obviously, it doesn't exist. So what is going on? So we can see standard library panicking. This is standard library, not our source code. Slice mod, this is this file they mentioned. Slice mod, so again, not our code, but here we finally get to our code, and it tells us at 4. So we see here, right here, 4. So pretty cool. It tells us what our code's called, and we can also see what called our main function. So here you can see that our main function was called by this. Toolchain stable Rust library core ops function RS. So pretty cool. We get a little stack trace, so that's great. Patatas is back. What's up? I believe this part of backtraces needs an update because in 1.47, I believe they changed how backtraces are displayed. Awesome. Yeah, I was going to say, it was telling us the correct spot in our file and wasn't telling us that it was a standard library throwing the issue. So great improvement. And yeah, maybe we can submit a PR to this book to have that updated. That'd be pretty cool. So awesome. So we have our nice new stack trace, but very cool that I like that we can get a cool stack trace from that. So that is awesome. All right, so we see our backtrace. There's a lot of output. The exact output you might see may be different depending on your operating system and Rust version, which we've seen, right? In order to get backtraces with this information, debug symbols must be enabled. Debug symbols are enabled by default when using cargo build or cargo run. Oh, very cool. Without the release flag, as we have here. That's pretty awesome. So if we just did this with Rust C, we compiled the code and ran it, we wouldn't get these nice debug codes, right? In the output in listing 9.2, line 17 of the backtrace points to the line in our project that's causing the problem. So we saw that, right? So pretty cool. We'll come back to panic and when we should and should not use panic to handle error conditions in the to panic or not to panic section later in this chapter. Next, we'll look at how to recover from an error using result. Yes. So Patatas in the chat said, notice that we have less steps. Yes, we have far fewer steps in our backtrace than they have here. Probably because of these optimizations in 1.47. Pretty cool. All right. Recoverable errors with results. So these are not panics. These are ones that we want to recover from. We've seen these, we've used these, but now we can actually understand them. Most errors aren't serious enough to require the program to stop entirely. Sometimes when a function fails, it's for a reason that you can easily interpret and respond to. It might be one that you've expected, right? You're asking someone for a string input. They put a number, something you expect and you want to give feedback on. For example, if you try to open a file and that operation fails because the file doesn't exist, you might want to create the file instead of terminating the process, right? You try to read a file that doesn't exist. If it doesn't exist, you create it. Recall from handling potential failures with the result type in chapter 2 that the result enum is defined as having two variants, the OK variant and the error variant as follows. So it's an enum that looks just like this. The T and the E are generic type parameters. We'll discuss generics in more chapter in chapter 10. Yo, who's excited for chapter 10 next week? I'm pretty excited. Everything's been leading up to this moment. Chapter 10, it's everything. Everything's in there. What you need to know right now is that T represents the type of the value that will be returned in a success case within the OK variant. So if it's successful, T represents the type that will be returned in the OK variant. And the E represents the type of the error that will be returned in the failure case with the error variant. Because result has these generic type parameters, we can use the result type and the functions that the standard library has defined on it in many different situations where the successful value and error value we want to return may differ. Really cool, powerful stuff. Excuse me. Let's call a function that returns a result value because the function could fail. In listing 9.3, we try to open a file. So I'm going to just create a new, project. So I'm just going to do cargo new, and we'll call this recoverable errors. CD into there. And let's open that up. All right. Let's close this out. Okay. So we're going to go ahead and import a file from the standard library here. File system, file is what we want. And we're going to say, let's f equal file open hello.txt. Really quick before I forget, I'm just going to update my settings so that Rust is handled with the correct number of spaces, because I keep forgetting to do that. And we'll do editor. Perfect. All right, great. Close that out there. All right, so we have let f equal file open text. And we can see here right away when we hover, we can see that it's unused, so pretty cool. So how do we know file open returns a result? We could look at the standard library API documentation, or we could ask the compiler. If we give f a type annotation that we know is not the return type of the function and then try to compile the code, the compiler will tell us that the types don't match. The error message will then tell us what type of f is, so we'll know. Let's try it. So this is a really cool example. So we talked about this maybe a few sessions ago. We've talked about it a few times, but we talked about really leaning into the compiler. And this is a really good example of that. We know that the compiler is going to give us very detailed information, and even in most cases link us to the documentation where that information comes from. So if we don't know the type of something, by just hovering, which in this case we do because we have our awesome system here that's going to show us exactly what the return type is, and we can see there the return type is IO result file. But if we didn't know that, we can lean on the compiler to tell us that information. And so what we could do is we could say f, we can call it, let's say it's a signed 32-bit integer, and right here it's going to complain. It's going to tell me, this isn't the correct return type. But if I didn't have this IntelliSense, let's say I'm just using Vim or something, whatever. If I just run this here, let me get out of your way again. If I just run this, cargo check or cargo run, I'll do cargo check in this case. You can see it's going to tell you expected I32 found enum standard result. So it's telling you the type it expects. Patatas in the chat said, I always use the unit type because most things don't return the unit type. So instead of I32, what Patatas in the chat is saying is use the unit type because most things aren't going to return a void, unit type. So that's a great thing to try out. So if we do cargo check, again, you'll see that message and tells you what the return type is. Found enum, expected unit type, found enum, standard result. And you can see in the success case, it's going to return a file. In the error case, it's going to return an IO error. So really cool. Lean into that compiler. Again, everyone triggers compiler issues. It's not just like, oh, you're a noob, you're getting all these messages. Pros, everyone, all the rustaceans of all shapes and sizes, we're leaning on this. This is important. It's there to help you, and this is a really cool, I like that they put that in the book because I think that's a really cool use case for leaning on that. And in our case, we can just look here. So if you have the VS Code plugin, I've been told in the chat to check out Rust Analyzer. We'll have to install that. But check it out. We get it right here. We can see found enum, right, result standard file. So in the success case, we're going to get this. Let me see if I can hover. Yeah, so in the success case, we're going to get a file. And in the error case, we're going to get an IO error. So we're going to get a file system file or an IO error. Pretty cool. So what I could say here is I could say this is of type results. And I can just put right here, we could do file or error. And we're all good, no complaints. And if I run cargo check, you can see that it's just telling me I have an unused, you can see it's just telling me I have an unused variable, and that's it. So pretty cool. All right, that's awesome. So, here they used unsigned 32. So, and they're showing you the output. So it tells us that the return type is of file open is either a file or an error. The return type means the call to file open might succeed and return a file handled that we can read from or write to. So it can return a file handle that we can read or write to. The function call might also fail. For example, the file might not exist, or we might not have permission to access the file. The file open function needs to have a way to tell us whether it succeeded or failed. At the same time, give us the file handle or error information, right? So it's like, hey, it worked, here's your file, it didn't work, here's the information. The information is exactly what the result enum conveys. In the case where file open succeeds, the value in the variable f will be an instance of OK. So it's not going to be a file, it's going to be an instance of OK that contains a file handle. In the case where it fails, it's going to be an instance of error that contains more information about the kind of error that happened. We can use a match statement to inspect these. And so we're going to do that here. So let's go ahead and do a match. So we're going to say let f, and again, matches are expressions. So we can do assignment with them, right? And we're redeclaring f here, which is shadowing, which we learned in chapter 2. So we don't need to say f. We could have made f mutable, but instead we're going to shadow f because we want it to stay immutable after we've gotten the file, right? We want to try to use immutability as much as possible in our favor. So we're going to use shadowing. We're going to say let match, and we're going to match on f. And if it's OK and we have that file, well, then we'll set f equal to that file. Otherwise, if it's error, we're going to get that error message. We can leverage that error message in our panic. So we can panic and we can pass it that problem opening the file. And here we're doing, remember, because the error, we're going to print out, in this case, we're using the display, not the debug. Or I'm sorry, in this case, we're using the debug, not the display. So this is the debug formatter. And so I'm going to say error. And again, we want to semicolon that, right? So pretty cool. Now F is still saying it's unused, but we've shadowed it, and now we have a match on it. Using a match expression to handle the results. Note that like the option enum, the result enum and its variants have been brought into scope by the prelude. So we don't need to specify result : before OK and error variants in the match arms. So that's why we can just say OK. We don't have to say result : because they're brought in by the prelude, which is again is everything that's imported by Rust by default. So here we tell Rust that the result OK returns the inner file value out of the OK variant, and we then assign that file handle value to the variable F. After the match, we can use the file handle for reading or writing. The other arm of the match handles the error. In this example, we've chosen to panic, and there's no file named hello text in our current directory. We run this code, we'll see the following output from the panic macro. So in this case, you can see they're calling file open hello text. I don't have hello text, so if I do the same thing here and I call cargo run, we're going to get problem opening file, not found, message no such file or directory. In the chat, Patatas is saying standard IO error actually implements display. Ah, awesome. So we could also do this is what Patatas is saying. So if we run this now, you'll see that's the display version. Pretty cool. All right, so now what we can do is we can put a real file that we have and see if that works. So let's look at what other files we have here. So we have a cargo toml. Let's try cargo toml. We may have to go up a directory, but let's try it out and see what it looks like when we get the actual file. Cargo run. Cool. Unused variable, one warning omitted, but we're good. We actually were able to find the file, so pretty cool. And it's just telling us that we haven't used it. So that's why it's saying, hey, put an underscore and we won't complain about that. So pretty cool. All right, let's dive in further. Matching on different errors. The code in listing 9.4 will panic no matter why file open failed. That's the code we just wrote. It's going to always panic no matter what the failure is. It's not actually checking any more detail. It's just throwing the error, right? What we want to do instead is take different actions for different failure reasons. If file open failed because the file doesn't exist, we want to create the file and return the handle to the newly created file. If file open failed for any other reason, for example, maybe we don't have permission to open the file, we still want the code to panic, right? In the same way it did previously. So what we can do is we can add an inner match expression and match on that error. So that's what we're doing here. So we'll try the same thing. So what we'll do is we will go down here, close that out, and we're just going to do a match. Error. We can match on the kind of the error. And so within our match, we're either going to get OK. Oh, sorry. So here we're going to match on the kind, and it says we have two different kinds. So we have error kind not found, and we'll do another match. And what we'll do is we'll try to create the file. That's why we're doing a match. We'll file create hello.txt. And let's change this back also to hello.txt. All right. We'll create that file. And then if we are successful, we'll return the created file. Otherwise, if we're an error, and we're using different, notice we're using different names here, right? Because we don't want to conflict with that. So, and we're going to do panic problem, and this may be a permission thing that this could come up, but let's just say with problem creating the file, and we will do a debug here, other error. So oh, sorry, E. We want to use E. And then if it's not if we're not dealing with that kind of error, then we have a different error if it's not a file not found error. And for any other kind of error, we simply want to panic, and we can actually do this on a single line if we want to. We can say panic, and we'll say problem opening the file. So in the first case, problem creating the file. Here we're doing problem opening the file, and we're going to pass it other error. All right, so here we're matching on the kind of the error, and we can see here there's an issue. Fail to resolve use of undeclared type or module error kind, use of the undeclared type error kind. So what we can do is we can import this. So what we can do, let's see. So we can look at what this returns. It returns an error kind. And so let's see. So let's see if we can import that. So that's coming from error kind. Let's see if we can pull that in. Nope, that's not a thing. Let's see if it's in standard. Nope. So let's see. Oh, they have it here. It's from IO. Cool. So we've now imported error kind, and we're going to match on that. Now let's try running it. So let me just move over here, out of your way once more, and we'll try running it. And we get nothing because I think it created the file. And there it is. There's our hello text file. So it actually successfully created it. Very cool. Awesome. All right. Let's go over this part. So the type of the value that file returns inside the error variant is IO error, which is a struct provided by the standard library. The struct has a method kind that we can call to get an error kind to figure out what type of error it is. The enum IO error kind is provided by the standard library and has variants representing the different kinds of errors that might result from an IO operation, in-out operation, right? The variant we want to use is error kind not found, which indicates the file we're trying to open doesn't exist yet. So we match on F, but we also have an inner match on error kind. So we match on that initial F error, and then we do another match on the actual kind of error. If the error is a not found error, well, we try to create that file, and hence the other match, because that could also fail, right? That also returns a result. If we're not going to see that it's a not found, we'll just print out the other error and panic. Condition we want to check the inner match is whether the value returned by error kind is file not found. If it is, we try to create the file with file create. However, because file create could also fail, we need a second arm in the inner match expression. When the file can't be created, a different error message is printed. The second arm of the outer match stays the same, so the program panics on any error besides the missing file error. Pretty cool. There's a lot of match. The match expression is very useful, but also very much a primitive. In chapter 13, you'll learn about closures. The result T, E type has many methods that accept a closure and are implemented using match expressions. Using those methods will make your code more concise. A more seasoned Rustacean might write this code instead of listing 9.5. Now, before I do that, we learned about something last week, Clippy, right? Let's try Clippy on this and see what Clippy says. Oh, well, it's complaining because I'm not using F. But like, all right, so let's do this. Let's say, it's clear. So it doesn't say anything, probably because our code doesn't do much. But let's see what how they're optimizing it down here, or because maybe our code's pretty good. So let's see what they say down here. All right. So here's another way to do it. I'm just going to copy this. Cleaner, version using closures. All right, so let's see what this cleaner version looks like. So in this cleaner version, they have let f equal file open hello text, unwrap or else. So this is interesting, right? They're using unwrap or else. Error. So this is, we learned a little bit about this last week. We saw this, but we haven't learned it yet in the book. But we know that it's basically like a inline function here. Unwrap or else error. If error kind not found, file create, unwrap or else error. So it's basically saying, if it's not successful, error, panic, problem opening file, error. So it's not explicitly handling the OK case, but it's using unwrap or else, which if we were to highlight it, we can see returns the contained OK value or computes it from a closure. So remember, OK is going to have a value associated with it. So in this case, this is going to return the contained OK value or computes it from a closure. And so in this case, we have error. If it's an error, we do this. So pretty cool. I'm sure we'll learn more about that. I'm excited. Although this code has the same behavior, it doesn't contain any match expressions and is cleaner to read. Come back to this example after you've read chapter 13 and look up the unwrap or else method in the standard library documentation. Many more of these methods can clean up huge nested match expressions when you're dealing with errors. That's awesome. I'm excited to learn more about this, because I can see this is already much simpler. Okay. Shortcuts for panic on error. Unwrap and expect. We've seen expect before, so let's see it a little more. Using match works well enough, but it can be a bit verbose and doesn't always communicate the intent. The result T-type has many helper methods defined on it to do various tasks. One of those methods called unwrap. It's a shortcut method that is implemented just like the match expression we wrote on listing 9.4, so the code above here, right? If the result value is OK variant, unwrap will return the value inside that OK. If the result is the error variant, unwrap will call the panic macro for us. Here's an example of the unwrap in action. So let's check out that. I'm just call this function unwrap in action, and we'll see what it looks like. So we have let's f equal file open hello.txt .unwrap. And so what I'm going to do is I'm going to just comment out this code really quick. And I'm going to call unwrap in action. And again, we have a hello text, so I'm just going to remove that file. All right, I'm going to step out of your way here and run that. So here we have, oh, well, I had to add a semicolon there. Sorry about that. Let's add that. All right. All right, so here we go. We have the same panic. Panicked at error rust unwrap on an error value kind not found. No such file or directory. So really cool, a little simpler, more verbose. So Patatas in the chat says you can also use a match guard, but that's explained in chapter 18. Ooh, not quite there, but very cool to know that there's a lot of different ways to do this stuff. I'm excited to get there. Thank you. All right, so pretty cool, much simpler, especially if we just wanted that first case. But if we're going to handle this other case, I think we'll need that unwrap or else option from before. So really cool. So again, we just did this. If we run this without the hello, we see the message. Perfect. We ran it without the existence of the file, so we saw that message. That was great. Let me just go ahead and comment that out, and we'll just bring this stuff back. All right, another method, expect, which is similar to unwrap, lets us also choose the panic error message. Using expect instead of unwrap and providing good error messages can convey your intent and make tracking down the source of your panic much easier. It won't be as generic. You can put your own message. The syntax of expect looks like this. So let's do another function here. We'll say expect in action. It sounds like a Manning book. Let f equal file open hello.txt.expect. And so here we're going to give it a message. So just like unwrap, but it can take a message. And we'll say failed to open hello.txt. We'll also say, what up, Twitch? Woo! Or YouTube. If you're watching on YouTube, we love you just the same. All right, so I'm going to go ahead and call this up here. Let that out. Clear. And run it. And I'm just going to go ahead and move out of your way again so you can see. And we got failed to open hello.txt. What up, Twitch or YouTube? Woo! Very cool. So that's awesome. I like that because you can give an explicit message and you'll know exactly what's going on because you wrote the message. So you can indicate, hey, it's probably because we did this or couldn't open file. You can be more explicit. So I really like that. And we've used that in the past in some code. So it's nice to actually see why and how it works and what it's actually a shortcut for. That's what I always love. You know, one thing you don't get when you, and maybe some people prefer this, but one thing you don't get when you just dive right in without reading about the stuff, and usually I am very much a dive right in person without reading the actual details of the language, is you miss out on some of that stuff, like how it looks when you do it the hard way or the verbose way versus what it's like when you use these simple functions. So if I were to just jump in, maybe I would have learned expect and never learned the match example, and maybe that's fine. Maybe I never need to use that. But one of the things that I find valuable about reading this material is to kind of understand the different ways to do things and the benefits. For example, in JavaScript, right, I'm going to use for each, map, reduce, but I know how to do a for loop, know how to do a while loop. It's good to know both. Gray Jack in the chat, what is up? What theme is that? Looks a lot like my personal theme. This is Monokai Ocean. So it's similar to Material Ocean. Yes, it is Monokai inspired. It's Monokai Ocean, similar to Material Ocean. So it's got that blue, gray, slate hue to it. I really like it. We were just before this in the last session using All Hallows Eve for the Halloween theme. But yeah, this is Monokai Ocean. Highly recommend. I alternate between Monokai Ocean, Synthwave 84, and occasionally a seasonal looking one, which you'll see when we get into some of the seasons. We saw All Hallows Eve. I got a different one for the holidays. Sometimes I bust out some autumny looking ones. So we'll be switching it up. Great question, Gray Jack, and thank you for being here. All right, so very cool. We saw the verbose way. We see the simple way. Awesome. Because the error message starts with the specified text, failed to open hello text, it will be easier to find where in the code the error message is coming from. If we use unwrap in multiple places, it can take a lot more time to figure out exactly which unwrap is causing the panic because all the unwraps print similar messages. So very cool. All right, propagating errors. When you're writing a function whose implementation calls something that might fail, instead of handling the error within this function, you can return the error to the calling code so that it can decide what to do. This sounds similar to a try catch where you throw an error, right? If you have something where you're using promises, you can throw it up the chain, similar to that. Grayjack, if one day you like to test mine is called Monokai Grayjack. Oh, yeah, I'll definitely check that out. We can do it right now. So Grayjack in the chat has a theme, Monokai Grayjack. Let's see if we can find it. There we go. All right, let's do it. We're gonna turn it on right here, Grayjack. Let's do it. Let's try it out. Bam. We got pastel. Ooh, I like that. Very cool, very cool. See, this is the beauty of being in the chat. You could take part in this stuff. I'm liking this pastel one. Let's see what else we got. Let's go to Grayjack. We got pastel and the the two different options. I like the pastel, actually. I think I'm going to go with the pastel. This is great. Thanks, Greyjack. See? And now we have a new theme. Awesome. So, anyone likes this theme? Monokai Greyjack. Greyjack's in the chat. Check it out. It's got some nice pastels. We're going to be using it for the rest of the session. Let's go. Awesome. So, we can propagate those errors upward. Pretty cool. For example, listing 9.6 shows a function that reads a username from a file. If the file doesn't exist or can't be read, the function will return those errors to the code that called this function. So good for if you're writing library code or something like that. So we got here main source read username from file. So what I'll do is I will create a new project just so we have this stuff organized. Cargo new, and we'll call it propagating errors. Propagating. Are we using underscores? We've been using errors. Okay, we'll use it like this. All right, we're gonna go into propagating errors, and here I'm just gonna pull it up. Source main. Free flying here. All right, so let's go ahead and copy this. I'm just gonna copy it so that we have it. It's easier. Oh, that didn't work out well. Let's do this. There we go. Oh, hold on one second. There we go, there we go, there we go. All right, so we have our file here now. We have our match. And let's see what's going on. Get rid of that. Get rid of that. Weird. Something's going on here. All right, hold on one second. Let me just get rid of this whole file here. And we'll copy this again. Okay, there we go. So, weird. I don't know where this is coming from. Unless it's up here. I can't see it. Anyway, so what do we have here? We have... Oh, you know what it is? Hold on one second. Let's just go back to what we had. Sorry, I'm just having a weird time pasting this. There we go. Okay. Let's just go ahead and... Oh. Type it out here. Huh, what is happening? Oh, my AutoHotkey or something is failing. Let me close this altogether. Don't save it. Let's go back here. There we go. And let's just delete this whole thing. And we'll start here. So we'll do use. We're going to pull in file system file. Use standard IO. And we're going to use standard IO read. In fact, what we're going to do though is we can actually just do this, right? I believe is the way to pull in both. Something like that. Standard IO and use standard IO. Let's do that for now. And there is a way to pull in both though. And then we're going to need read username from file. We're also going to need a main, so I'll just put that back here. Function main. Read username from file. And here, I'm just going to copy this function like that. Beautiful. All right, so now we have a main function. We have a read username from file. And let's see what it does. Greyjack in the chat. Cool. It's great that you like it. I fully support semantic coloring. So if your language plugin supports that, it will colorize according to semantics. That is awesome. Dozeboy in the chat. What is good? Loving the emojis. Sushi flame. Wow, it's a new one for me. Love it. What up, Doze? Thank you for stopping by. All right, so let's break this down. Again, we're talking about propagating errors up. Read username from file. So it's going to return, this is the return type, a result that's either going to have an OK of a string or an error of a IO error. Let F, so we're going to open up this file. We're not using expect or anything. We're just going to try to open the file. Then we're going to match on F. We've made F mutable, so we're going to match. If it's there, we have the file. If not, we're going to return the error. So that's key. We're returning the error. We're not panicking. Here, we're going to create a mutable variable called s that is just a string. We're going to try to take the file, read it to a string, and we're going to pass it s. If it finds it, right? So if it's able to read that from the string, we're going to get s. Otherwise, we're going to get this error. And there's no semicolon, so we know that it's returning this, right? There's no semicolon for this match, so it's going to return the result of this. So the result will either be OK with an S or error with an E. So we know that here we're explicitly returning. We're saying, hey, return the error. So we're not handling it, we're not panicking, we're allowing the calling function to handle that. And here, because it's the last line of the function, again, implicit returns, if we leave off that semicolon, matches our expressions. So we're either going to have, this function's either going to turn, it's returning this whole result, which is either OK or error, which is why we get this. Right? All right, pretty cool. Let's read a little bit about it. Okay, so it says this function can be written in a much shorter way, but we're going to start by doing a lot of it manually in order to explore error handling. This is what we just talked about, right? Going deeper into it so that we understand how things work. At the end, we'll show you the shorter way. Let's look at the return type of the function first. And we talked about this. It's a result that's either going to return an OK containing a string value or an error containing an IO error. So you can see here, if this function succeeds without any problems, the code that calls this function will receive an OK, right? That holds the string, the username that this function read from the file. So it's either going to hold that string. If this function encounters any problems, well, then the code that calls the function will receive the error value, and it'll contain an instance of an IO error that we see here. That'll contain more information about what the problem was, where it occurred, and so forth. We chose IO error as the return type of this function because that happens to be the type of error value returned from both the operations we're calling in this function's body that might fail. So both file open and read to string return an IO error. So we're just going to return that. The file open function and the read to string method both return IO errors. The body of the function starts by calling the file open function. Then we handle the result value returned with a match similar to the match we've seen before. Instead of calling panic in the error case, we return early from the function and pass the error value from file open back to the calling code. So we're not panicking, we're passing it back to the caller. So that's different than what we've seen. And that's going to be the error value of our result. If the file open succeeds, we store the file handle in the variable f and continue the flow of the code. The next thing we do is we create a string called s, and then we call read to string method on the file handle that we have from f to read the contents of the file into s. The read to string method also returns a result because it might fail, even though file open succeeded. So we've succeeded step one, which is this part here. Now we're here, we're creating a new string, but this might also fail. So we need to handle that as well, right? So we need another match to handle this result. If read to string succeeds, then our function has succeeded and we returned the username from the file that is now in S wrapped in an OK. So what does that mean? If it succeeds, we read to string the file, we have S, it's stored there, we just return it. We return an OK with S. So if we're able to read that into a string, we return it. Otherwise, we return the error with the error. Clam Watson is in the chat. Yo, sorry I'm late, chat. What up, Teach? What I missed? Can you start over? Yeah, we're starting all over. All right, back to the beginning. Clam, thank you for hopping in. Don't worry, it's great for all of us to get caught up on where we're at. What we're doing now is we're learning about error handling. We're doing error propagation. We've seen what it's like to panic when we have errors. We just throw a panic. Now we're seeing what it's like to propagate errors up by returning them. So pretty cool. It's been I thought error handling going into this would be really boring. We've actually written more code, I think, in this chapter than we have in the past few, and I'm enjoying it. We're writing actual programs, which is nice. So loving this. All right, so read to string. If it succeeds, we return an OK containing the string, otherwise an error containing that information. Also, Clam in the chat, we've switched our theme. Greyjack created an awesome Monokai theme. We're checking it out, loving it. We're using the pastel version right now. I'll put a link to that in the show notes as well. All right, so pretty cool. We're returning this. And you can see here, if it fails, we return the error value in the same way that we return the error value in the match that handled the return of file open. So it's very wordy, but all we're saying is these are treated very similarly, right? And again, notice this. We're not explicitly using the return keyword because there's implicit returns from functions. You just leave off the semicolon. And so this match is an expression. So we can return this whole thing, right? So pretty cool. We don't need to explicitly say return, again, because it's the last expression of the function. The code that calls this code, this is the important part, this is the propagation. The code that calls this code will then handle either an OK or an error. So it can use a match, it can use an expect, and we'll write that in a second. So it can handle that. It either contains the username or an error. We don't know what the calling code will do with those values. If the calling code gets an error value, it could call panic, it could crash the program, use a default username as a backup, or look up the username from somewhere other than a file, for example. We don't have enough information on what the calling code is actually trying to do, so we propagate all the success or error information upward so that the caller can handle it appropriately. We let our function focus on what it's handling, and we let the caller determine how they want to handle the error success. We just report it back. That's the propagation. The pattern of propagating errors is so common in Rust that Rust provides the question mark operator to make this easier. Okay, so here we're going to see a shortcut. So this is the long way, as they mentioned. We're going to see the short way. A shortcut for propagating errors using the question mark operator. So here we have an implementation of that same function using this new cool operator. So I'm just going to copy this, and we're going to just name it something different. We're going to say read from file short way, and we'll call this read from file long way. And again, what we can do, since we're not using it, we can just throw on that underscore, and it won't give us that highlighting. All right, so here read from file is short way. So let's look at what's different. So right away, we have our file open. We've appended a question mark to the end of that. The next thing that stands out is the read to string. We no match. We just appended a question mark. And then the last thing we do is return OK with that string value. So let's see what's going on here. The question mark is placed after a result value that is defined to work in almost the same way as match expression was defined to handle the result. If the value of the result is an OK, the value inside that OK will get returned from the expression. So what does that mean? On line 26, if this results in an OK, and remember, open returns a result. If it results in an OK, we're going to get that file and we're going to store it in F. That's what that's saying there. If the value of the result is an OK, the value inside the OK will get returned from this expression. So we'll actually get that value, right? And the program will just continue. If the value is an error, so if this fails, it can't find this file and there's an error, well then the error will be returned from the whole function as if we had used the return keyword, so the error value gets propagated to the calling function. So this is the same, this is equivalent to this. So it's basically saying, if you're good, store the file handle in F, otherwise return that error to the caller function, right? The function that called this. Same thing here. The difference between what the match expression from this listing does and what the question mark operator does is that error values with the question mark operator called on them go through the from function defined in the from trait in the standard library, which is used to convert errors from one type into another. When the question mark operator calls the from function, the error type received is converted into the error type defined in the return type of the current function. This is important. Okay, what are we talking about here? Well, we've specified that the return type of this function is a result that either returns a string or an IO error. Now we just happened to get lucky in that our read to string and our open file both naturally return IO errors. They just do. You can see it in the actual function type here. So we can see result file, and we can probably see if we put a bad return type, we'll see what the error type is. So if I just put this here, we can see what the error is, and it's going to tell us it returns standard file on OK, standard IO error on error, right? So we got lucky. Now, what this is saying, though, is that the question mark will actually handle a scenario where if it returns a different error, it will convert it into the error that you want it to return. That's super powerful, right? We don't have to do the conversion. That's pretty cool. So in the context of 9.7, the question mark at the end of file open will call the return value inside an OK to the variable f. If an error occurs, the question mark operator will return early out of the whole function and give any error value to the calling code. The same thing applies to the question mark at the end of read to string call. The question mark operator eliminates a lot of boilerplate and makes this function's implementation simpler. We could even shorten the code further by chaining method calls immediately after the question mark. That's really cool. So I'm going to just copy this, and we're going to create another function called shortest way. And so we have let mute s equal, so we're creating that string in advance, the new string, file open, hello text with a question mark. If it's successful, we're just going to chain read to string, and we're going to pass it that mutable reference to s so that it can actually store the value of read to string. So the result, if it's okay, it's going to put it in s. If it's not, again, it's going to return the error. We need that question mark at the end. And then we return s. Let's step through this really quick. We create a mutable variable s. That's just a new string. We then call file open hello world text with that question mark. So what it's going to do is it's going to try to do it. If it's successful, it will continue. If it's not, it will return an error. What kind of error? An IO error. If it's successful, it then calls read to string on that file handle. If that's successful, it will put the result of that read to string in our mutable s and then return OKS. If it's not successful, it will return an IO error. So really cool, obviously much slicker than this. Really cool. You may have seen question mark in other languages. In some languages, they call it the existential operator. In JavaScript, it's been added. It's called optional chaining. I believe CoffeeScript called it the existential operator. And in those cases, it's a little different. I know in JavaScript, we use it to check if something is defined. So, I mean, it's similar here, but we actually have strict types behind this, where in JavaScript, it's just checking if the thing preceding the question mark is defined before trying to access further properties of that object or whatever the type is. But so this is pretty cool, though. This is going to handle a lot of boilerplate for us. I really like it. So just to dive in on what we're doing here, we've moved the creation of the string s to the beginning of the function. That part hasn't changed. Instead of creating a variable f, we chained the call to read to string directly into the result of the file open. We have a question mark at the end, and it will return OK if it's successful. Otherwise, we'll return error. So just like we talked about. Speaking of different ways to write the function, list 999 shows there's a way to make this even shorter. Cool. Get out. Yo. Come on. You know what that means? We're going to have to change the name of this function to shorter. You know what I'm saying? This is going to be a shorter way. But they were low-key. They're like, yo, it's not the shortest way, though. There's still a shorter way. We're about to do that right now. This is the shortest way. What is it? Look at this. What the hell? Look at this. We're just going to call, wow, they low-key were like, there's actually just a function that does it for you. You just have to call read to string. Wow, look at this. Who would have thought? Not me. So, what does this do? So we're obviously going to have to import this, which is why it has us doing that. So first I'm going to go ahead and import fs. And I believe we can do this. There's some way to do this. Some syntax sugar, I forget, but maybe it's that. I don't know. There's some syntactical sugar where you can do that. Maybe somebody in the chat knows. We learned it, but I forget. Okay, so we're going to import file system, and now we have fs read to string. Let's see what it says in the docs. Read to string. Read the entire contents of a file to a string. Wow, look how easy that is. So Patata said, in case you're wondering, in the case of an error, the question mark operator do a return. So it returns, and this is what it does. Error, and it calls from E. So it's calling that from function, which they mentioned, and wrapping it in an error. That's awesome. Thank you, Patatas. So check this out. Read to string is just a function on the FS file system module. Read entire contents of the file to a string. Greyjack commented, if you're going to do that, you have to put self file. Good to know. So, pretty cool. Let's see what it says. This is the shortest way. Reading a file to a string is a fairly common operation. So, Rust provides the convenient read to string function that opens a file, creates a new string, reads the contents of that file, puts the contents into a string, and returns it. Of course, using fs read to string doesn't give us the opportunity to explain all of the error handling, so we did it the longer way first. So we got to see the long way and the short way. So I see what you're saying. So if you're going to do that, you have to put self file. Great, Greyjack, I'm going to do that. So Greyjack taught us how to do this. We would have to pull in self and file. fs self file. Awesome. That's a nice little shorthand. I like that. So self is the module itself, and then awesome. Thanks for the help, Greyjack and Patatas. Awesome. Look at that. We're making the shortest code possible here. So pretty cool that this is such a common operation. They make it really easy. And you've probably done this in other languages where it is like a pretty standard thing. But again, the benefit of doing it the long way, and the reason we're doing this is to get experience on, why we do things. It also gave us good experience on how to do error handling if we do want to go into the details of error handling. And probably something you wouldn't do if you jumped right into the code, right? If you jumped right into Rust and Googled, how do I read a file? You'd probably get this, but we're getting the benefit of knowing what it's doing behind the scenes and how we can dig in deeper and break those operations up. So really cool. And it's cool to see that Rust said, hey, this is common enough that we should just make a module for it, right? So pretty awesome. Okay. The question mark operator can be used in functions that return result. The question mark operator can be used in functions that have a return type of result because it is defined to work in the same way as the match expression. So that's all of our functions so far have return of type result, and that's why we can use the question mark. The part of the match that requires a return type of result is return error E. So the return type of the function can be a result to be compatible with this return, right? Let's look at what happens if we use the question mark operator in the main function, which you'll recall has a return type of the unit type. So let's try it. Let's see what happens. Let f equal file open hello.txt. And we'll use that, and we'll see right away. Attempts to open a file in read-only mode. Well, that's not the actual error. The error we want here is this. The question mark operator can only be used in a function that returns result or option, or any type that implements standard ops try. Cannot use the question mark operator in this function that returns the unit type. So really cool, great error messages. Awesome that we're getting it right from our Rust language thing, whatever we call it, language server. Just really fantastic stuff. I love it. So what I'm going to do is comment that out, though. It's been huge. No, we won't do that. Too close to home. Ugh. All right. There's like definitely a little gnat flying around. Anyway, let's move on. So the error points out that we're only allowed to use the question mark in a function that returns result. Oh, so yeah. So in the chat, you said Greyjack is saying can also be used with the option returning function. So anything with try, which is pretty cool. So the error points out that we're only allowed to use question mark in a function that returns result or option or another type that implements standard ops try. When you're writing code in a function that doesn't return one of these types and you want to use the question mark when you call the other functions that return result t, you have two choices to fix this problem. One technique is to change the return type of your function to be a result if you have no restrictions preventing that. The other technique is to use a match or one of the result methods to handle the result in whatever way is appropriate. The main function is special, and there are restrictions on what its return type must be. One valid return type for main is the unit type, and conventionally another valid return type is result TE as shown here. So we could actually change our return type, results, there we go, results, and it's either in the successful case it returns the unit type, otherwise it returns box dyn, I don't know what that is, I'm sure we're going to find out, error. And we got to import that. Also in the chat, Patatas is saying we can go even further with how we write our imports here, because they're both coming from obviously the standard module. We could do that. And he says, don't actually do this though. Trice Tank in the chat. Couldn't resist, could you? Yep, absolutely. Tank's rolling out. I want to know what beer Tank's drinking right now. I know he's got one on hand, especially during this election. All right, so we got results, unit type in the success case, and box didn't error in the failure case. Now, what is dyn error, and why is it complaining at me? Expected enum result, box static, found unit type, implicitly returns unit type. Oh, it's because we're not doing anything. So like, let's just return. There we go. No complaining. I returned OK. I returned a result with the unit type. So now it stopped complaining. Okay. The box dyn error type is called a trait object, which we'll talk about in the using trait objects that allow for values of different types section in chapter 17. For now, you can just read box didn't error to mean any kind of error. All right. Using the question mark in a main function with this return type is allowed. So now we can actually use it. Let's return to the topic of how to decide which is appropriate to use in which cases. Oh, sorry. So now that we discussed the detail of calling panic and returning a result, let's talk about which one is appropriate in which type of scenario. So just quick recap. We're using the question mark here. We're returning a result. We've seen what it's like to panic all over the place. I'm sure a lot of people have seen what it's like to panic, especially during these times, right? COVID, election. Voodoo Ranger, fantastic selection there from New Belgian Brewery. Awesome. All right, so we've seen panic. We've seen it in code. We've seen it in the real world. We've seen handling results, right? We're waiting for some results in the case of this election. But here we're talking about results, returning the result type. Really powerful stuff. We've also seen how to return result type from the main function, which traditionally has a return type of the unit type, meaning it just runs and it's done. Okay, let's see when to use these. To panic or not to panic? That's the question. Isn't that always the question, right? So how do you decide when you should call panic and when you should return a result? When code panics, there's no way to recover. You could call panic for any error situation, whether there's a possible way to recover or not, but then you're making the decision on behalf of the code, calling your code that a situation is unrecoverable. So if we wrote code that read a file and returned an error, if it failed to read a file and we panicked, well, now whoever's using that code knows that anytime they call our code, there's a chance it will panic. And, we may not be our library may not want to handle that. Sometimes maybe it does, but in our case, maybe we want to just let the caller handle it, and that's when you would use result. So when you choose to return a result value, you give the calling code options rather than making the decision for the calling code. The calling code could then choose to attempt to recover in a way that's appropriate for its situation, or it could decide if an error value in this case is unrecoverable. So it can call panic itself and turn your recoverable error into an unrecoverable one. Therefore, returning result is a good default choice when you're defining a function that might fail. So default to using result. So, in rare situations, it's more appropriate to write code that panics instead of resulting in a result. Let's explore why it's appropriate to panic in examples, prototype code, and tests. So, it's saying it's appropriate to panic in examples, prototype code, and tests. Well, clearly it's appropriate in tests, right? I mean, we'll figure that out. We haven't even learned how to write tests yet. We're going to get there. Then we'll discuss situations in which the compiler can't tell that failure is impossible, but you as a human can. The chapter will conclude with some general guidelines on how to decide whether to panic in library code. All right. Examples, prototype code, and tests. So these are examples, prototype code, and tests are when we should panic. When you're writing an example to illustrate some concept, like they've done a bunch in this book, right? Having robust error handling code in the example as well can make the example less clear, and it just looks like a lot of code. In examples, it's understood that a call to a method like unwrap that could panic is meant as a placeholder for the way you'd want your application to handle errors, which can differ based on what the rest of your code is doing. So in examples, it's okay not to do the error handling, just panic. Similarly, the unwrap and expect methods are very handy when prototyping before you're ready to decide how to handle errors. They leave clear markers in your code for when you're ready to make your program more robust. So start out with those, and then you can always, when you're ready to make your code more robust, you go up and you clean them up. If a method call fails in a test, you'd want the whole test to fail, right? That's the point. You want to know when there's an issue. Even if that method isn't the functionality under test, because panic is how a test is marked as a failure. Calling unwrap or expect is exactly what should happen. So that a test fails if it panics. All right, cases in which you have more information than the compiler. This is like, we're getting into like Among Us stuff. It's like when you got all, It would also be appropriate to call unwrap when you have some other logic that ensures the result will have an okay value. But the logic isn't something the compiler understands. So, as the author, this is going to have an okay. I'll give you an example. This main function, I know this is never going to error because I'm explicitly returning the okay with the unit type. So this, I know what's happening, but the compiler doesn't know, right? So you still have a result value that you need to handle. Whatever operation you're calling still has the possibility of failing in general, even though it's logically impossible in your particular situation. Perfect examples are again, logically impossible, but still. If you can ensure by manually inspecting the code that you'll never have an error variant, it's perfectly acceptable to call unwrap. Here's an example. So an example, standard net IP address, let home IP address, parse, unwrap. So it's impossible because, hey, it's a hard-coded string. Of course it's going to be able to be parsed and unwrapped. We can run it. It's not going to do anything because it doesn't return anything. We're creating the IP address instance by parsing a hard-coded string. We can see that 127.0.0 local is a valid IP address, so it's acceptable to use unwrap here. However, having a hard-coded value string doesn't change the return type of the parse method. We still get a result value, and the compiler will still make us handle the result as if an error was a possibility, even though we know it isn't. The compiler isn't smart enough to see that the string is always a valid IP address, but we know. If the IP address string came from a user rather than from being hard-coded into the program and therefore did have the possibility of being a failure, right? Maybe it came from input, maybe it was a variable. We definitely want to handle the result in a more robust way instead. Guidelines for error handling. It's advisable to have your code panic when it's possible that your code could end up in a bad state, right? That's pretty clear, but it's good to say it out loud. In this context, a bad state is when some assumption, guarantee, contract, or invariant has been broken, such as when invalid values, contradictory values, or missing values are passed to your code, plus one more of the following. So let's read that line again. In this context, a bad state is when some assumption, guarantee, contract, or invariant has been broken, such as when invalid values, contradictory values, or missing values are passed to your code, plus one of the following. The bad state is not something that's expected to happen occasionally. Your code, after this point, needs to rely on that value being there and can't do anything. It's in a bad state. There's not a good way to encode this information in the types you use. So if someone calls your code and passes in values that don't make sense, the best choice might be to call panic and let the person using your library to the bug in their code. So alert the person using it to a bug in their code so they can fix it during development. Similarly, panic is often appropriate if you're calling external code that is out of your control and it returns an invalid state that you have no way of fixing and no way of anticipating. However, when failure is expected, it's more appropriate to return a result than to make a panic call. Examples include a parser being given malformed data or an HTTP request returning a status code that indicates a failure or a rate limit for 3s, 400 pluses, right? In that case, a result is appropriate. When your code performs operations on values, your code should verify the values are valid first and panic if the values aren't valid. This is mostly for safety reasons, and we know that we're making very safe code, type safe code with Rust. So this is mostly for safety reasons. Attempting to operate on invalid data can expose your code to vulnerabilities. This is the main reason the standard library will call panic if you attempt an out-of-bounds memory access. Trying to access memory that doesn't belong to the current data structure is a common security problem. Functions often have contracts. Their behavior is only guaranteed if the inputs meet particular requirements. Panicking when the contract is violated makes sense because a contract violation always indicates a caller-side bug, and it's not a kind of error you want the calling code to have to explicitly handle. In fact, there's no reasonable way for calling code to recover. The calling programmer needs to fix the code. Contracts for a function, especially when a validation will cause a panic, should be explained in the API documentation for the function. That's a lot to take in. Here's the summary. Give you the just like elevator pitch. You want to always give the most information possible. You want to let the user know if there's an error that has happened that can be expected. You want to panic when there's an invalid value, you don't know what to handle. But to any chance you get, you want to ensure the validity of something before performing an operation on it. And if you do return a result or return a panic, you should expose that in your API so the caller knows what to expect. You always want to be transparent with these things. So just again, to recap this, just these last sentences I think are important. Panic when the contract is violated makes sense because a contract violation always indicates a caller-side bug. So if your caller is incorrectly calling your function, a panic is correct. That will never work. Let them know early, right? In fact, there's no reasonable way for calling code to recover. The calling programmer needs to fix the code. Contracts for a function, especially when a violation will cause a panic, should be explained, right? Okay. However, having a lot of error checks in all of your functions would be verbose and annoying. Fortunately, you can use Rust's type system, and thus the type checking the compiler does, to do many of the checks for you. If your function has a particular type as a parameter, you can proceed with your code logic knowing that the compiler has already ensured you have a valid value. For example, if you have a type rather than an option, your program expects to have something rather than nothing, right? If you're not using an option, you're using a type, it's expecting it to always be there, right? Your code then doesn't have to handle two cases for the sum and none variance. It will only have one case for definitely having a value. Code trying to pass nothing to your function won't even compile. That's great. So your function doesn't have to check for that case. It's not even an option. It's not something, no pun intended, right? It's not even an option. So another example is using an unsigned integer such as unsigned 32-bit integer, which ensures the parameter is never negative. So you can ensure it with your types. So you can lean on the types for that. Creating custom types for validation. Let's take the idea of using Rust's type system to ensure we have valid value one step further and look at creating a custom type for validation. Recall the guessing game in chapter 2 in which our code asks the user to guess a number between 1 and 100. So let me pull that up. So guess the number. We had a number between 1 and 100. We actually didn't specify. We should change it. Guess number between 1 and 100. So at least they know. All right, so we asked them to guess the number between 1 and 100. We never validated that the user's guess was between those numbers before checking against our secret number. We only validated that the guess was positive. In this case, the consequences were not very dire our output of too high or too low would still be correct, right? It's not going to, I mean, if you guessed 1,000, it's still too high, but it would be annoying for the user to not know what the bounds were. But it would be a useful enhancement to guide the user toward valid guesses and have different behavior when a user guesses a number that's out of range versus the user types something bad like some letters. One way to do this would be to parse the guess as a signed 32-bit integer instead of an unsigned 32-bit integer to allow potentially negative numbers. And then add a check for the number being in range. So again, one way to do this would be to parse the guess as a I32 instead of an unsigned 32 to allow negative numbers, and then add a check for the number being in range. So let's change it. So for guess, we used 32. We're going to change it to a signed 32-bit integer. And then we're printing this, but then we can do a check here. We'll say if guess less than 1 or guess greater than 100. Let me just move this here so you can see. So I just added this here. I'm doing a check here. We're going to print the secret number will be between 1 and 100, and we'll continue. So and if we did this, obviously it can be less, but so if we run this, let me go into that guessing game. Input your guess, -50. Secret number between 1 and 100. All right, so let's guess 50. Too big, we'll guess 25. Too big, we'll guess 13. Too small, we'll guess 16. Too small, 17, 18, 19, 20, 23, 22, 21. It was 21. We guessed it. We won. Okay. Sorry. Had to finish the game. Can't let it beat me. You know. All right. So the if expression checks whether a value is out of range, tells the user about the problem, and calls continue to start the next iteration of the loop and ask for another guess. After the if expression, we can proceed with the comparison between guess and the secret number, knowing that the guess is between the range. However, this is not an ideal situation. If it was absolutely critical that the program only operated on values between 1 and 100, and it had many functions with this requirement, having a check like this in every function would be tedious, right? So if we required that this value always be between 1 and 100, adding this if check in every function would be tedious. So can we encode that somehow in a type? We're going to see in a second with some validation. Instead, we can make a new type and put the validations in a function to create an instance of the type rather than repeating the validations everywhere. Ooh. That way, it's safe for functions to use the new type in the signatures and confidently use the values they receive, knowing that they're going to be between 0 and 100. We're going to use a struct. This is awesome. I love this. Okay, so pub struct. So again, this is just public. That's all that means. Public struct guess, and it's going to have a value. Its value is a unsigned 32-bit integer. And here we're going to create an implementation block. So this is what this is here. Remember we learned about implementation blocks. Guess, and we're going to say pub function new. So when we create a new one, remember because we do guess : new. So when we call new, we're just overriding the default, and we're going to say we're given a value. It should be of type unsigned 32-bit integer, or sorry, signed 32-bit integer. And it's going to return a guess, which is the structure, right? It's going to return the whole structure. And here we can put that check, copy that out, put it over here, and just change a little bit. If it's not between that value, right, we're going to go ahead and we're going to panic in this case, which is good because it's unexpected. So we're going to panic guess value must be between 1 and 100. And then we're going to go ahead and return, if it's okay, we're going to return guess and the value. All right. And this is just the same as that, right? Okay. We're going to create another public function called value. Again, all these functions have access to self, which is the instance of the struct. This is going to return the 32-bit integer, and it's just going to return self.value. And that's how we'll get the value from it. Okay, let's see what we're doing here. So first we define the struct named guess that has the field named value that holds the assigned 32-bit integer. So again, it could be negative, could be positive. This is where the number is going to be stored. Then we implement an associated function named new on guess that creates instances of guess values. The new function is defined to have one parameter named value of type signed 32-bit integer and to return a guess. The code in the body of the new function tests the value to make sure that it's between 1 and 100. That's what's happening here. So it's doing that validation for us. And if it's not, it's going to panic, which will alert the programmer who's writing the calling code so that they have a bug they need to fix before using it. So it'll alert them right away, because creating a guess with the value outside this range would violate the contract of guess new. The conditions in which guess new might panic should be discussed in its public-facing API. So if we were making this public, we would want to expose that in our API so callers of this or users of this guess struct would know what they're in for. We'll cover documentation conventions indicating the possibility of a panic in the API documentation that you create in Chapter 14. If value does pass the test, we create a new guess with its value field set to value parameter and return the guess. Next, we implement a method named value that borrows self, doesn't have any other parameters, and returns the signed 32-bit integer. This kind of method is sometimes called a getter because its purpose is to get some data from its fields and return it. The public method is necessary because the value of guess struct is private. So the value is private, so this is making it a public getter. We could have made it public. Right, we could do, and then we can get rid of that getter, but we're going to use a getter in case we want to do other stuff with it. The public method is necessary because it's private. It's important that the value field be private, so code using the guess struct is not allowed to set value directly. So that's why we don't allow it to be set directly, because then it'll bypass our validation. Code outside the module must use the guess new function to create an instance of guess, thereby ensuring there's no way for a guess to have a value that hasn't been checked by the conditions in guess new. So we can't let them set it. We keep it private, and let's put that in here. I think that's very valuable. So I'm going to put here, we use a getter so that value can remain private and therefore cannot be set explicitly. Setting it explicitly without using the new function would bypass the validation, which we don't want. Perfect. All right, let's try using it first, and then we'll read the summary. Okay, so let's try using it. So what we'll do is guess is, instead of going to be a string new, we're gonna keep it as a string new here because we're gonna read the line. We're mutating it, but here instead of returning the number, we're gonna turn a new guess. So we're gonna change guess to a guess, and of course parse. We see here we're gonna have to handle it explicitly. We're gonna say guess new num. And so that's going to create a new guess with that value, and it can panic. Now, because it can panic, we don't need to handle this like a result type. It'll just panic. So if we wanted to handle that panic, we could, but what we'll do is we'll just let it panic if this happens. So we're going to create a guess new. So now we have a type guess, and then here we'll want to say we can get rid of our validation here, and we can access get dot, and again we're going to want to grab the value but it's a function. So we're going to say guess.value, and that should get us the value. Now guess compare we can't do. We have to do guess.value compare. And so let's see if this works. So, oh, sorry, maybe I'll see that. So I changed guess everywhere to call guess.value to get the value. I've changed this here to create a new instance of a guess, and I've changed the type here to a guess. So let's try running it and see what we get. So cargo run. Please input your guess. I'm going to input -4, and there right away we get a panic. Guess value must be between 1 and 100. So I'm going to run that again, and I'm going to write a valid value of 50. Too small, but we're not getting the panic. Great, too big. Too big, so we're going to go between 63 and 50. Let's go ahead and go 55. Too small, let's do 59. Too big, 57. Too big, 56. Got it, 56. Let's go. Awesome. So pretty cool. And if we wanted to handle that panic, again, we could wrap this, right? And handle that way. But pretty cool. We've now used this guess. We have that validation. Really cool stuff. All right. Now, we're about to wrap up. Let's read the summary. Rust's error handling features are designed to help you write more robust code. The panic macro signals that your program is in a state that it can't handle and lets you tell the process to stop instead of trying to proceed with invalid or incorrect values. The result enum uses Rust's type system to indicate that operations might fail in a way that your code could recover from. You can use result to tell your code that needs to handle a potential success or failure as well. Using panic and result in the appropriate situations make your code more reliable in the face of inevitable problems. Now that you've seen useful ways to the standard library use generics with the option and result enums, we'll talk about how generics work and how you can use them in your code. Now, what does that mean? That means chapter 10 is next. And anyone that has been following knows that chapter 10 contains everything, because everything is always wait till the end of chapter 10. So chapter 10 is be nuts. That's why we're not going to start it now. We are at 11:43. We're going to call it. But before we do, I want to modify this, right? Because I want the same behavior. We're going to quickly convert this to use a result instead of using a panic. What does that mean? Well, that means that value, right? When we set this, creating this new could create an issue, right? So we're going to return, instead of a guess, we're going to return a result that either returns a guess. This way we can continue. We can say, hey, enter a new value. Or it returns an error. And what kind of error? We can just do a standard IO. Well, we'll just do an error. And we'll pull that in from standard IO error. Okay? So now we have to deal with the maybe type. And so if the value is greater than less than 1, if it's out of range, we're just going to return error. And we're going to return this. Let's just go ahead and copy this. Right? We have to return it. What does this say? Expected struct IO error found string. So we just need to say from. I think that will work. No. Standard convert from string is not satisfied. The trait from string is not implemented for standard error. Let's do. All right, let's see. How do we return an error here? So I guess what we'll want to do is, let's see. It should tell us. So expected struct IO string error found. So let's see if we can do. Is that a function? Let's see. Let's look at the error API. let's see what we have available on error. So let's go to really quick. We'll go here. We'll go to standard IO error. Pull up our docs. Error new. That's what we need. So we'll do return error new. And then for error kind, we'll say other, and then we'll pass it our string. Wait, let me get that back here. So we'll do error, create a new error, error kind, other, and again, we have to import error kind from here. Awesome. So let's see what this is saying here. We have expected result. Okay, so we have this error. Now we need to wrap it in our error here like this. Perfect. So that's our error. And now in the correct case, we need to return our value, and that's just okay. And we wrap our thing there. So now we're returning a result. So this now returns a result. Self.value is still going to be fine. It's going to return this. And now what we'll do is here, this can fail. So we'll actually just do expect, or is it accept? Accept, right? That was what we did, accept. We see, we used it here, accept in action. Accept, that's what we want, yep. So we'll use accept and we'll say, well, in this case, it's actually okay because what's going to happen is it's going to print guess a value. It's going to already print that. So we'll just do unwrap. And let's try this out. So let me clear it. Let me get out of your way again. All right, so I'm going to run cargo run. Guess the number. I'm going to say -50. And there we go. Error, guess must be between 1 and 100. So what we can do is if we don't want that panic, what we can do is we can do a match. So we'll say match. And we can match on guess new. And for our okay, we'll have value. I'll return value. Otherwise, if we have an error, instead of panicking, we'll take that error and we'll just do the same thing here. We'll just continue. Actually, we'll just continue. Continue. And we'll just say, all right, let's try that. Clear it out. Cargo run. -50. There we go. So we didn't get the error. Oh, so we definitely want to still at least print that error. So let's do that. Let's do create a block here. We're going to print ln, and we'll print the error, and then we'll continue. All right. So format argument must be a string literal. You might be missing a string. So what we'll want to do is just format this. So we'll say like that. There we go. All right, let's try this now. So I'm going to cancel this down here. I'm going to just abort this. Clear it out. Cargo run. Enter -50. And there we go. Guess value must be between 1 and 100. So we'll guess 50 again. Too big, we'll do 25. Too big, we'll do 13. Too small, we'll do 15. Too small, we'll do 19. Too big, we'll do 17. We win, 17. Woo! All right, awesome. So we learned we're at just about 10:50, perfect time to wrap it up. We will be covering chapter 10 next time, the long-awaited chapter 10. Maybe we'll have some special event or something, but it's been long-awaited. Thank you for hopping by and watching this. Really appreciate it. Again, I will be posting, if you missed any of this in the previous series, I will be posting them up here on YouTube. You can find all the previous videos. You'll find this video. It usually gets posted the following day, so tomorrow in high definition. It should be up, and I'll tweet when that goes up. So if you want to know when things get put online, follow me on Twitter here as well. You can see my Twitter handle above. The YouTube, you can just search Tom McGurl, or if you scroll up in the chat, the message is there. Everyone, thanks for the chat. Thanks for participating with Tadas in the chat. Not a good practice, but you could return a string for the error too. Very cool. So yeah, everyone in the chat, thank you. We got Greyjack giving us an awesome new theme. Again, the code's going to all go up here in our Learn Rust Live repo. This is on my GitHub, which you can find at my name, github.com/myname. Chapter 10's next week. It's going to be crazy. It's going to be real. If you like what you've seen here, thank you for stopping by. Follow. If you like the videos on YouTube, hit the subscribe and you'll get notified when new videos go up. I appreciate it. It's been awesome to see people comment. GitHub/myname, can't find you. Nice. Give me a lull in the chat there. Clam Watson in the chat said, went to GitHub/myname, can't find you. Very clever. I wonder if that is actually someone's username. But github.com/TomMcGurl. You got the Twitter below, YouTube. Check out the videos on YouTube. You can watch them at whatever speed you want. We have folks commenting they're watching on 1.7 speed. So I talk like this really fast like a chipmunk. All the videos are there. Everything will get posted. I've been really loving this. Again, it's Wednesday, but we usually do this on Tuesday from 9 p.m. to 11 p.m. I may add another day, so I may start doing Tuesdays and Wednesdays. It's been really fun, so we'll see how that goes. So expect some more content. We're going to keep going with the book. Chapter 10 is next week. It's going to be crazy. A lot of stuff got pushed off to Chapter 10. There's going to be a lot of hype where we learn about traits. I'm pretty excited. I hope you're excited. Another thing I wanted to mention, there was another book that I started checking out that I think is worth mentioning. I'm going to go ahead and just pull this up really quick. So on the Rust website, which is rustline.org, there's another book called Rust by Example. I started going through this a bit on my own this week. It's a little bit more about exercises and reading code. Not as much, some explanation, but kind of in a different order. And it's been pretty cool. So if I find any good exercises while I'm going through it that aren't just reading code and actually have us doing stuff, I'll definitely do some of those on stream. Another thing is I'll be putting up a series on how to run Rust inside a Docker container for those of you that don't want to install Rust on your machine or maybe your work machine, and you just want to work in an isolated environment that you can easily destroy and are familiar with Docker. We'll do that. So again, thank you everybody for coming by. If you're watching on YouTube, thank you for the views. I appreciate it. Hit that subscribe button or like button and keep up to date on when new content gets posted. It's been awesome time learning about error handling. Thanks again in the chat for those attending. Greyjack again said, check out Rust Analyzer. And I'll get that semantic highlighting. I definitely do that. We're going to install Rust Analyzer and we'll have that ready for next stream. Everybody have a good night. Again, I'm Tom McGurl. Thanks for attending. Really appreciate it. Shout out to everyone and have a good night. We'll see you next week for Chapter 10. Later.